Hi, welcome to another video. A particle moves in the xy plane so that the position at time t is given by these parametric equations. X is t cubed minus 12t and y is equal to t squared, for t being between minus 5 and 5. The units of distance are meters. The graph shows the path of the particle and the direction of travel at the point P is given by that vector there. Find dy by dx in terms of t, hence show the value of dy by dx at p is minus 2/5, remembering that p is 9,9. Find the time in which the particle is travelling in the opposite direction to that at p, and find the Cartesian equation of the path given x squared as a function of y. So, just having a look at part C. So if we look here, if I run this slide along here, you can see that the particle will move, although it's a little bit small. The particle will move, and here at this particular point, actually the gradient is actually minus 2/5. Now somewhere over here it will have the same gradient, but we'll be going in the opposite direction. If you look at that, you see over here, in fact that's the actual point. It will actually be going in the opposite direction. So if you click the tangents there, you'll see that they are both parallel at that particular point. At this particular point, shall I say. And if we move this along, it gets its whole direction of travel. And then, obviously, this is the point that we're going to actually find algebraically here, where it's in the opposite direction. The thing is, at these 2 points, the gradient on the curve is actually the same, and that's what you've got to need to realise. Now, the GeoGebra app, I will put in the notes of the video so you can have a look for yourself. Okay. So, if we got x is t cubed minus 12t and y is t squared, for t being between minus 5 and 5, then if we did dy by dx, so we just differentiate normally with respect, dy by dt, we're just going to get 3t squared minus 12. And then if we do dy by dt, we're going to get 2t, but we don't want to find dy by dx, so we have to use the chain rule. So using the chain rule says dy by dx is dy by dt by dx. Then dy by dx is equal to 2t times 1 over this. You have to take the reciprocal of this one, because this is what you want here. So we can write this as 2t over 3t squared minus 12. Okay, for part B, we need at p, we require dy by dx be equal to 2/5. So we take this and put it equal to minus 2/5. Okay, so we'll just cross multiply to solve it. So we're going to get 10t is equal to minus bracket 3t squared minus 12. Spanning that bracket, we're going to get minus 6t plus 24. Be careful with the signs. Bringing everything over to the left-hand side, we're going to get 6t squared plus 10t minus 24 is equal to 0. These are all divisible by 2, so we're going to end up with 3t squared plus 5t minus 12 is equal to 0. And then this factorizes quite nicely, so we're going to get 3t times t, which is going to give me 3t minus 4. T plus 3 is equal to 0. And that will give me t is 4 over 3 and t is minus 3. Now one of these will give me the value of p. Now the most likely one is going to be minus 3, but you could try both and you'll find that only one will work. So using t is equal to minus 3, x is t cubed. Minus 12 t, so it'll be minus 3 all cubed minus 12 times minus 3. So minus 3 cubed is minus 27, and minus 12 times minus 3 is plus 36, so that will give x is equal to 9. So that's looking good. And then y will be just minus 3 squared, which will give 9. So obviously the value of t is going to be 9. The gradient is going to be minus 2/5 shown. Okay, so we want to know when it's going to be travelling at the opposite direction. Well, if it's travelling at the opposite direction, to p, and then like I just showed you at the beginning, then dy by dx will still have the same value, minus 2 over 5, because the gradient of the curve will actually be the same, even though they're moving in opposite directions. And therefore t is going to be 4 over 3, the other value that we calculated doing part B. Okay, part D, so using t squared is equal to y, we're going to have the x is t cubed minus 12t. Now, we asked to express x squared in terms of y, so if we square both sides, we get x squared is t cubed minus 12t all squared. Expanding that, we're going to get t to the 6, we're going to get t cubed times minus 12t, so it's going to be a minus 12t 4, but we're going to get two lots of that, so we're going to get minus 24t to the 4, and then plus 144t squared. And then if we just rewrite this as x squared is t squared to cubed, still gives me t to the 6, 24t squared squared, plus 144t squared, and then replace t squared with y. We're going to get y, because why we can do that, because we know that t squared is equal to y. We're going to get x squared is y cubed minus 24y squared plus 144y. Okay, so we'll just have one quick look at the GeoGebra app again. So going back to the GeoGebra app, okay, if we run it along, we can see where it moves. Okay, we want the other point where it's like that, and that's going to be there because, just put that back there, because at that particular point, it will have the same tangent as there. Although it's going in that direction, this one's going in this direction, which is the opposite direction. Anyhow, the GeoGebra app will be in the notes of the video, the link to it, so you can try for yourself. I hope you've enjoyed this video, and maybe you can consider subscribing to my channel. But I thank you very much for watching, and I hope you've understood.